Welcome to the National Manufacturing Institute Scotland's inaugural Insight session. I'm Andrew Hamilton, and I work in the digital and metrology team alongside John Riley and Paul McCard, who will also be presenting today. In this webinar, we'll be describing the challenges facing the manufacturing sector when trying to exploit the added value of data analysis to support and improve the businesses. We will focus on the use of the Python programming language as a data science framework to overcome these issues by offering a flexible platform where multiple data sources in different manufacturing environments can be unified into a common architecture. We will describe the tools available for importing data and visualizing it, analysis libraries for machine learning and artificial intelligence, and the use cases that highlight the benefits using Python for manufacturing data science. This session is aimed at those who are considering adopting a new data science framework that will help them gain additional value from the data, or those who are beginning to use Python for data analysis supporting their businesses and research teams. We'll also be offering technical insight sessions in the coming weeks, which put into practice the tools described today. These are the speakers today, so myself, Andrew Hamilton, John Riley, and Paul McCard, who will be speaking later on in the presentation. Just some housekeeping slides for the online world. This webinar is being recorded and will be made available online. Your microphones and webcams are currently turned off for the session to avoid background noise. You can type your questions throughout the session via the chat tool, and hopefully one of the team members here will be able to answer your questions. Time will be allocated at the end for the speakers to answer your questions. You can also post questions using hashtag NMIS Insights on Twitter at NMIS Group. And please take some time to complete a survey that will be sent after the webinar. Probably would be a good idea just to start off to say, what is the National Manufacturing Institute of Scotland? The National Manufacturing Institute of Scotland, or NMIS, is a group of industry-led manufacturing research and development facilities where research, industry, and the public sector work together to transform skills, productivity, and innovation to attract investment and make Scotland a global leader in advanced manufacturing. NMIS will increase productivity by reducing barriers to innovation, stimulate investment and increase manufacturing competitiveness, catalyse job creation and strengthen supply chain links, inspire and attract talent, and equip current and future workforces with the skills they and businesses need. NMIS will also work with manufacturing businesses of all sizes across all sectors, providing benefits across the whole of Scotland. NMIS is operated by the University of Strathclyde and is supported by the Scottish Government, Scottish Enterprise, Highlands and Islands Enterprise, the High Value Manufacturing Catapult, Skills Development Scotland, Renfrewshire Council, and the Scottish Funding Council. The NMIS Group consists of two specialist centres: the Advanced Forming Research Centre, where the digital team, which myself, John and Paul are part of, is currently based, and the Lightweight Manufacturing Centre that opened in Renfrew in 2019. We were delighted to receive planning permission for the new NMIS building that will be next to Glasgow Airport, with an expected opening in late 2021. NMIS will also comprise the core elements: the digital factory, the collaboration hub, and the Manufacturing Skills Academy. We're already working on the digital factory as part of the digital team, and the Manufacturing Skills Academy is currently offering CBT courses across Scotland. If you'd like to find out more information about the National Manufacturing Institute of Scotland, please visit our website, email us, or catch us on Twitter. Now, that's enough introduction. Let's get started with the session. Manufacturers have always had to manage big data, whether the sources from equipment sensors, factory-wide efficiency metrics, or individual components. What has changed over the past few years is the availability of highly connected frameworks such as industrial IoT, the maturity of software analysis tools, and the lowered costs of analysis hardware able to handle this data-rich environment. The advent of highly connected digital factories offer unique opportunities to manufacturers who can successfully harness the added value that comes with big data, from deriving new analysis systems that assess component quality to supporting the decisions taken by managers and engineers on a daily or hourly basis. Aggregating data and conducting robust analysis across connected factories is challenging and can be expensive, which is why selecting the best tools for handling data is critical if companies wish to derive this additional value. Manufacturing data can be characterized by three main features that set us aside from other environments. First is the sheer volume of data that is generated. Individual processes in manufacturing environments can yield gigabytes worth of data in very short periods. This could overwhelm traditional analysis platforms when trying to visualize and analyze these data streams. Second, the sources and types of data are diverse, often using different timestamps and formats. This is also complicated by the competing communication standards used between the original equipment manufacturers. Pulling together this data into a common framework usually requires multiple tools and scripting languages. Lastly, within similar processes, there is often a high degree of variability in the data associated in the creation of seemingly identical components or processes. There is also an incredible amount of domain knowledge by staff that is not easily captured or incorporated into analysis. Any data analysis platform needs to address these challenges as we digitize our processes further and improve decisions based on these vast quantities of diverse and unique data sets. One framework that can meet the challenges posed by manufacturing data is the Python programming language. Python is a high-level, general-purpose programming language that has become the near-default language of choice for data science due to the extensive pre-built function libraries that are created and updated by an enthusiastic global community of developers. Python's flexibility has allowed it to dominate the data science domain. Whilst other languages exist, this flexibility allows implementation of solutions from aerospace, automotive to pharmaceutical manufacturing. The framework of Python is generalized enough that developers have created tools to allow connection directly with data sources, including Profinet and other industrial communication standards. It allows implementations of artificial intelligence that can analyze vast quantities of data, making use of analysis hardware like general graphics processing units. It has powerful data manipulation capabilities to align, resample, format, and process data streams into portable formats and unified pipelines. Applications can be quickly developed for deployment across almost any given environment. There are a lot of enterprise tools available for dealing with data, ranging from Excel to MATLAB. These tools do have advantages and are often targeted at the enterprise level. However, some of these platforms suffer from hard dataset size limits, have high cost, or do not have the necessary tools for deployment as the analysis and operational tools required by industry. In contrast, Python is an easy programming language to get started with, being regarded as one of the most accessible languages for absolute beginners, with free online training resources. Development of more advanced skills with languages is a linear progression and not commonly held as having a steep learning curve or being inaccessible at an advanced level. Python benefits from being open source, so it can be accessed at no cost. It has a massive online community, so issues of almost any nature will invariably have its solutions readily available online. Beyond the application of data science, Python is a language of high capability, from app and game development, blockchain, automation, and control, to name a few. Before we go into detail of Python, let's look at some case studies to see what impact has in practice. I'd like to describe a project from a sector that's quite advanced in embracing the potential of Python for data science, precision agriculture. In this project, there were over 200 discrete IoT-enabled sensors, 4 robotic devices totaling over 300 unique data streams, all continually producing data for a given farm. It was also expected that additional sensor platforms with their own APIs and associated data formats would be introduced over time. Our analysis system therefore needed to be adaptable and scalable. Data streams were integrated from various SQL databases using appropriate Python libraries. From here, the data was converted into pandas data frames, allowing months of continuous data acquisition to be contained in a single source. Backfilling and auto-population of various timestamps and data values allowed the creation of a single baseline. This underpinned all analysis that followed, as now all data streams could be compared directly, grouped into useful analysis chunks, and analysed for cross-correlation of features. Another important outcome was the potential to reduce the number of sensor systems by deriving the same decisions from a single sensor system that would normally require 2, and this was only possible by using advanced data analysis. This can reduce the total capital expenditure and operating expenditure by simplifying the hardware requirements to effectively operate a farm. Another case study was innovating a manual inspection process with an aerospace partner. By using Python as a software framework when developing the hardware solution, the acquisition and analysis of sensor data was highly efficient, as the sensor outputs could remain raw and be transferred across an ad hoc network with minimal comms development, keeping costs low for prototyping. The research team from each organization could work on a common Python platform, making use of code version control software. This accelerated development of This accelerated development of the analysis software that was intended to support decisions made by the engineers of the aerospace partner. Using the Python framework kept operating costs low, as both partners did not need to use proprietary systems not common to both organizations. This improved interoperability, which is critical for innovation. We've now seen some examples of Python can deliver impact in industry. So now let's look at some of the components in Python that make it such a useful tool. In particular, is libraries. These libraries are collections of functions with a common theme. Some are aimed at providing the tools to visualize data in intelligent ways. Others expand the range of mathematical functions available compared to the base installation of Python. Each of these are so well developed, they're almost a distinct entity in themselves, with hundreds of active developers and thousands of supporting developers all trying to improve and advance each library's particular focus. Numerical Python and scientific Python, NumPy or some SciPy for short, provide methods of manipulating arrays of data. These operations are optimized for code and processing efficiency, and so NumPy can be thought as the go-to ground-level toolkit for vector and matrix mathematics. It's therefore invaluable at the initial stages of a data science project, where analysis and understanding of data, as well as model prototyping, are key activities. SciPy provides the basic maths tools such as differentiation, integration, and gradient optimization, which are essential for data science at all levels. While they can be used directly as libraries, it's important to appreciate the role that SciPy and NumPy play in data science. These two libraries provide the core data structures and key maths functions for scientific computing in Python, providing all the tools needed for analysis, model design, and even development of fully fledged neural networks, although these would require significant amounts of development and coding at a mathematical level. This leads on to the importance of higher functioning libraries such as FastAI, PyTorch, and scikit-learn. I'll now pass over to John Riley, who will go into more detail of some of the most important libraries for addressing the volume and diversity of manufacturing data.
Hi there. Onto the slide. That's perfect. So why use pandas at all? Let's say you are working with some manufacturing-related data as a researcher or engineer. You will likely want to load, organize, and determine key statistics about your data. How can Python help you with this? What library would have the most impact? This will likely be pandas. Pandas is a fast, powerful, flexible, and easy to use open source data manipulation and analysis tool built upon the Python programming language. What does that actually mean? It means pandas can read and write pretty much any data structure you can think of, whether it be CSV, Excel, SQL, JSON, and many, many more. Pandas is written in Python, but the data analysis is actually executed using the programming language of C, which is a more efficient programming language to process large datasets. Any tools found in MATLAB or Excel you will find in pandas, as it has all the tools you expect of a data analysis program and much more. Pandas has been used in many different areas of industry and academia, from economics to environment, and from advertising to animals. If industry or academia has a lot of data which requires complex analysis and to be completed quickly, pandas will be involved. Let us discuss all the advantages of pandas and how it compares to traditional analysis tools like MATLAB and Excel. Unlike Excel, pandas does not limit you to the size of file you can analyse, while Excel limits you to a 2 GB file. The only limiting factor to pandas data size is the amount of memory installed in your computer. You hear programming and you probably think it's going to be more complicated than clicking on an Excel file. In pandas, it's really not complicated. Simply run these 2 lines of code in Python and you've accessed your data and are ready to process and analyse it. I'm sure you're thinking, programming doesn't allow you to view data easily or in a nice format. Well, pandas does. Simply type df.head to view your data as shown below, and pandas has automatically indexed your rows just like in Excel. Visually, pandas looks no different to Excel or MATLAB. What is amazing about pandas is to load and view a large file takes a fraction of the time it takes to do the same on Excel. In pandas, creating new data and columns is as simple as typing out a mathematical equation. In this used car dataset, do you want to know how old the car is and you know the year it was built? Simply create a new column with the name you want and subtract the year it was built from the current year. Pandas does that mathematical computation on all rows and creates a new column with the results. This example's equation and results can be seen here. How many clicks and movements of the mouse would this have taken you in Excel? A lot more than one line of code. Just as creating new data in Pandas is quicker, so too is the filtering of data. Pandas takes one line of code to create a complicated filter, and it achieves it using well-known logic syntax. For this example, we have created a filter which keeps any rows where the year is greater than 2019 and shows only rows where the manufacturer is Chevrolet. How long would this have taken you to do in Excel? How many clicks of the mouse? How long scrolling through lists? Well, I'll show you how long it took myself. As you can see, even with full knowledge of Excel and understanding of the task, it still took myself around 30 seconds to complete. Typing the code and filtering the data in Pandas would be completed long before Excel, the comparison becoming even greater when the dataset increases in size and the number of filters used. Which data to you is more easily understood? Excel, where the column is filtered but does not clearly state how, or Pandas, where the code also explains the filtering? Pandas has all the tools you expect: sum, max, min, median, mean, standard deviation, rolling window, and much more. The syntax used in Pandas for these functions keeps to well-known conventions which are used in most tools, allowing users previous knowledge to transfer easily into Pandas. Grouping data is also a breeze in Pandas. By simply choosing the column you wish to group by and which mathematical function required, the results are computed almost instantaneously. In this example, the data is being grouped by manufacturer, and we're looking to find the mean of the data. Pandas groups all the manufacturers and finds the mean of all numerical data it can. So in this example, it tells you the mean year an Alfa Romeo was built is 2006, the odometer is 40,295, and it is 13.5 years old in this dataset. With this one line of code, we have created meaningful information, and to do similar on other tools would have taken longer. In the next slide, I'll show you how long it took myself to create the same grouping of data in Excel. Again, with understanding of the task and knowledge of Excel, grouping the data and finding the mean still took myself over a minute. Compared to Pandas' one line of code and computation, it took a greater length of time to achieve the same goal in Excel. As data sets grow larger, the benefit of Pandas over other tools becomes even more obvious. I'll let this animation continue to the end to show you just how much more effort it took. As you can see, it's still loading when it's grouping the data here. And there you go, that's it finally. It achieved what Pandas did in one line of code. So we'll move on. When you've completed your data manipulation and analysis, Pandas allows you to output the data in multiple different formats with ease. If Pandas can read it, it can output it. Your input data came in a CSV format, and your next step is in JSON. Pandas can do it. You need your data saved in multiple different formats. Pandas can do it, and it can do it in one step, as shown in the code in this slide. Pandas does everything you would expect from an analysis tool and much more. Want to load large datasets quickly? Pandas does it. Want to manipulate and analyze data quickly? Pandas does it. Want your data read and written in different formats? Pandas does it. But most importantly, want repeatable and reproducible analysis? Pandas does it. Today, we've only scratched the surface of the Pandas library. if you do any type of data analysis, you need to start using pandas. Academia and other industries are reaping the benefit with it. Why aren't you? Now that we have shown a tool to import, manipulate, and analyze data, let's look at one of the main visualization tools, matplotlib. So, what is matplotlib? It is a Python library that specializes in the creation of static, animated, and interactive visualization of data. The tagline they like to use is, "It makes easy things easy and hard things possible." And they're right. Graphs you'd love to create but can't in Excel are possible in matplotlib. With a couple lines of code, you can create a beautiful and custom graph, and with a few more lines, you can create amazingly complex graphs with multiple subplots as shown on the right. Matplotlib can create all graphs you have learned to expect, like pie, bar, and line graphs. But it can create more interesting and elaborate graphs like scatter, heat maps, polar, 3D, and animated graphs, all of which can be joined on the same plot using subplotting tools. Matplotlib comes with many tools, so many tools, we could speak about them for an entire presentation, but today we'll only discuss the main and most impactful tools. Let's start off with plotting graphs. You can customize every detail of your graph, from minor and major ticks, the coloring of everything shown, line types, titles, axes, and legends, to name but a few customizations. If you think of something you want changed, you can change it. Subplotting is another brilliant tool of matplotlib. Have you ever wanted to group together graphs which are related and easily insert them into documents? Subplotting is a tool you need, as it can create one image with multiple plots. The image in the top right shows you an example of subplotting 4 different plots together. To create these, you create your plots as normal, but add a few extra lines stating to group them and choosing which position you want each plot to be in, saving you so much time in formatting plots and documents. The next tool you should know about is 3D plotting. Sometimes multiple plots do not clearly visualize the data, so something else is required, and that thing is 3D plotting. As data gets more complicated, so does representing it, and matplotlib makes it easy to create 3-dimensional plots with its easy-to-use libraries. The final tool I'll discuss is animations. Have you ever needed your data to be eye-catching, or wanted to represent your data in a dimension of time? And matplotlib has the tool. Animated plots allow you to show your data's change over time in a visually appealing and easily understood form. So why use matplotlib for data analysis? The library contains more advanced tools for visualizing data than Excel or other platforms, which helps with the understanding and identification of patterns. Analyzing and exploring big data sets can be completed easily and quickly with matplotlib, as coding is minimal for easy graphs and it makes difficult graphs possible. The plotting tools of matplotlib can also help show relationships between data points and variables. For example, using data correlation plots as shown in this slide, it can lead to a quicker understanding of relationships in your data. Matplotlib provides all the tools required for data visualization, which is clarity, accuracy, and efficiency, allowing data to be explained easily to others and showing the full potential of data analysis. I'll now pass you over to my colleague Paul McHard, who will discuss machine learning tools.
Thanks, John. That was great. So what we've gone over so far are some of the libraries which provide functionality similar to what you might expect from traditional software tools for data processing. And we've kind of given the argument for why Python's a better choice in these scenarios. But we're now going to move on and give a bit of an overview on some data science methods which are much more difficult or potentially not even really feasible with traditional tools. So talking about applications that might use machine learning or artificial intelligence primarily. So when you're working with these sort of algorithms, it can usually be quite a daunting task to get started with, because these are the sort of things that we see as quite hot topics in the news. They're mentioned alongside massive companies such as Google and Amazon, which are, huge corporations that are really data rich. And it's not often clear to see how these sort of tools can be applied in other domains or in situations which lack these kind of vast data resources. So what we're going to talk about is how that can be applied in manufacturing environments and how anyone can use machine learning and artificial intelligence to improve their workflow. So at its core, machine learning is just a method of developing software that can learn patterns without being explicitly programmed to do so. In manufacturing, these patterns, such as finding patterns related to the component strength or the condition that a machine is operating in, they're not always easy to see. So in this environment, machine learning can be a really useful tool. The algorithms used can be quite simple, such as finding a linear decision boundary that classifies if a machine will or will not continue to operate within given limits. Or you can also look at problems such as involving much more complex algorithms, analyzing video streams for identifying component locations non-intrusively on a shop floor. Or generally speaking, just create powerful tools to understand and track data and workflow around your site and find ways to optimize different elements that might be incredibly difficult to spot otherwise. Python has numerous libraries to support machine learning development at all levels. First one we'll talk about is scikit-learn, which is a great library to get started with in machine learning for manufacturing and data analysis. It features numerous algorithms such as support vector machines, random forests, and k-means clustering, which can be quickly applied to data sets that have been imported in Python. PyTorch Learn is one of the fastest growing and most popular machine learning frameworks. It was produced by Facebook and is entirely open source. It is popular in applications such as computer vision, natural language processing, and many other fields where deep neural networks play a key role. A big part of its popularity is because it's strong for GPU acceleration, which, because at the end of the day, machine learning is rooted in large-scale matrix multiplication, the ability to use GPUs and GPU clusters specifically can massively accelerate the processing speeds that you're working with. PyTorch additionally allows for the use of dynamic computation graphs, which, unlike static graphs, do not require lengthy, cumbersome definitions prior to runtime, and they're much more lightweight and easy to use for data science compared to libraries such as TensorFlow, which ironically is also most popular in its Python implementation. Lastly, PyTorch is regarded as being Pythonic, which means that coding in this library comes more naturally and intuitively to a Python programmer, using syntax that aligns closely to Python's typical language standards. Lastly, the FastAI library has a lot in common with PyTorch and uses quite similar processes. The overall goal of FastAI is to make machine learning accessible for all. There is also a focus on providing the tools for data scientists who deal with uncommon data sets, which are actually very common in engineering applications. Some of the most well-known applications of machine learning and AI are based on incredibly rich data sets available from Google and Facebook. In manufacturing, the challenges of data specificity means that data sets can have missing values, uncaptured domain knowledge, and other nightmares that hamper development of accurate models. FastAI provides a lot of great tools to try and overcome some of these issues. So what we're showing you in this slide is a Python script that imports all three of the previously mentioned libraries, scikit-learn, PyTorch, and FastAI. We're then using certain functions from these tools to generate a convolutional neural network that can analyze sensor acceleration data that may be found on a robotic arm or some other form of moving machinery. And a neural network is really just several layers, as we're seeing here. The first layer, and then the second two layers that we're seeing. The first layer is our input layer. So that is just effectively an array of all the data that you're loading into the network. Layer 2 that we're seeing is just a processing layer, and then our third layer is our output layer. So we'll get into the more specific details of these in further sessions, but you can really just think about this as, if you don't have any understanding of neural networks at this point, you can think of this as kind of sets of, like, layers of matrix multiplications that allow you to just process data and analyze to find patterns. So what we're doing here is we're using scikit-learn to split the data into training and test sets, which we're seeing just, not sure which line. Sorry, we're seeing that in the top of the script, and we're using that to ensure that there's a balance between the classes that we're using. We're also using functions from scikit-learn for assessing how well our models perform after training. PyTorch is used to build the model itself, which is what we're seeing in that model equals nn.sequential, and then the lines that follow on below it. And we're using that to specify the layers, as we're seeing the channels and other hyperparameters that allow us to fine-tune the model for a given task. We're also using FastAI to arrange data into blocks that can be sent to a GPU for faster processing than would be available using only CPU power. It's worth noting at this point that while we're using all three of these libraries for illustrative purposes, with the base functions that we're showing, any of these algorithms can do this.
Sorry about that. I think we dropped out. Andrew, you want to take over here then?
Yeah, so just, can everyone hear me okay? Yep. I'll just take over from Paul. Basically, we've used all three of these libraries for illustrative purposes, but you could probably just use one of these libraries to get started. Scikit-learn is a good one to just get a sort of basic understanding of machine learning. There's actually advanced tools within scikit-learn, but it's quite an easy to access library, mainly because it has plenty of online examples and good documentation of all the functions that are contained within the library itself.
Oh, sorry about that.
Oh.
Sorry, that happened earlier to me while John was speaking as well. It dropped out. But, sorry, how was I dropped out from? Where did we get to?
Oh, sorry. We'll move on to the next slide now.
Okay. Sorry about that. Integrating Python into your manufacturing environment may be easier than you'd expect. In its most basic application, you can simply download and install Python and then get it running on your laptop or your desktop, load in your data set, and then just get to analyzing it through some of the methods that John was describing earlier. However, Python can also be loaded onto a server and can be run using, it can be able to utilize GPU stacks in that sense for much faster application. And you can use that at the same time to directly connect to data sources and control systems using some of the connectivity means that Andrew touched on earlier. This means that you can access all the benefits of machine learning for edge computing near the sensor node, or have a Python script aggregating data sources at a higher level as shown in the sensor stack. Visualization, while applicable at all levels, can be used at a front end, and you can integrate that into web platforms to support analysis from raw sources and also to visualize and demonstrate the results that you're seeing. Python is an incredibly powerful tool for manufacturers across all domains as it helps exploit a common theme: data. For businesses to maximize the potential of their data, accessing, manipulating, visualizing, and analyzing these valuable sources will be key, and Python can offer a framework to accelerate all of these processes. So I'd just like to take time to thank everyone that's come along today and listened to our presentation this morning. This has been intended as providing a kind of business case for using Python for data science, as opposed to using traditional data processing tools such as Excel. If you'd like to know more about Python for manufacturing data science, NMIS will be running technical insight sessions based on the libraries and tools mentioned in this presentation, and we'll be diving much deeper into Python for data processing, visualizing data, and examples of machine learning implementations. These sessions are aimed at those who will be working with manufacturing data, those who have some experience with programming or Python, and also those who are interested in learning more about Python through engineering data examples. The session dates will be announced at some point in the coming weeks. In the meantime, I'd encourage those who are interested in Python and its potentials to support and drive forward their data-related innovations for manufacturing to consider looking at some of the following resources that we've got at the bottom of the screen here. Anaconda is a absolutely excellent piece of software. It's a one-stop shop for getting Python programming up and running on your personal or work system. It comes with really useful development tools such as built-in IDE. It's got Jupyter notebooks, which are an incredibly efficient and powerful way of running and sharing Python code. It also has all of the most important libraries for data science and useful tutorials built in for getting started. It's entirely free and will likely be your choice for getting started. It's one of the best options for doing so, and it also has enterprise versions for larger organizational support. Additionally, there are hundreds of available online courses for getting started with basic up through advanced Python programming, and you can go to websites such as learnpython.org for free online tutorials. But this is obviously by no means the only free online training resource, and because Python is such a popular and well-supported language from the community that is built up, there are hundreds of resources out there. And finally, as I tried to touch on earlier, I hope I actually managed to even say it, but when I was talking about fast AI, we'd recommend that if you're interested in getting started with machine learning and you're comfortable with programming, then fast AI is a great place to go to start with. So from all of us at the National Manufacturing Institute for Scotland, thank you for your attention, and we'll now welcome any questions that you have.
Hi Laura, are you able to unmute everyone and we can maybe open up for any questions we have?
Hello, yes, no problem. If people want to send the messages through chat, or alternatively let us know on the chat if you'd like to speak, and I'll unmute.
Looks like we've got someone writing.
Yeah, I think we've got someone that wants to ask a question.
The ID began with 70, I believe.
Hey there.
Hi there.
My name's Robert Leckie. I work in the pharmaceutical industry. I've been in the industry for about a decade. I graduated from Strathclyde in 2007, by the way.
Oh, great.
It's nice to see what you guys are doing. One of the things that's interesting about the pharmaceutical industry is how out of sync they are with technology. One of the problems that you've got is that you work under what's called CGMP. So I don't know if you know about that, but it's basically red tape. So anything that's going to be put into a human, the process to get it there is very, very lengthy. As a result, regulators and pharmaceutical companies are very, very cautious, and when they invest in systems and such, they tend to be stuck there for a long period of time. So you tend to see sort of antiquated bits of software, but that thinking and that process kind of breeds this environment where they're always several years behind the industry. So we had a guy who came to site last year. He's a really talented guy, and he knew all about Python. And he gave me a book about Python, and he told me to go and download Anaconda, and I did. And I'm halfway through it, and I'll get back to it as well. But I was going through all the exercises, and in terms of sort of NumPy and analysing data and things like that, I can definitely see its use. But he tried to take that and use it because we've got what's called quality management systems, where there's big bits of data and it tells you basically you do your root cause analysis, you put your investigations and all that sort of stuff in there. Anyway, over the years you amass quite a bit of data, so he started using Python and he was CSV files in order to try and manipulate this data and understand it better. But it went down like a lead balloon. That's the sort of frustration that you meet in the pharmaceutical industry. People are quite averse to change. But sooner or later they all catch up. But just to get back to John's point, I know you were talking about like the Excel versus the line of code. So I can look at what you did there and I can see that I don't want to leave the keyboard when I'm at the keyboard, because I know that if I need to touch my mouse, I'm wasting time. So I'm very conscientious of that. So I know the power in that. But I guess my question is that what's in the pipeline, or given what I've said, what do you think we could do to try and mitigate that level of rejection almost of technology in industries like the pharmaceutical industry, and indeed other areas where people are very happy to use Excel because it is user-friendly and available to everybody?
Yeah. Well, that I think what you would have to try to explain to them is how is it reproducible? Like what I said in the slides, is it reproducible analysis? Like when you see people filtering in Excel, you don't actually know how they filtered the data. Well, you could sell pandas as being, it's very explicit, which will probably be what your regulation also looks for. They don't want any unknowns. So with your data analysis, you will have a script, Python and pandas, which explicitly states the data analysis you're doing. While in Excel, yes, you can get to the solution of all the data being filtered, but there's no room for anyone else to check how you've got to and verify your work. So it allows reproducibility and allows other people, say regulators, to come in and verify your analysis. That's the way I would try and sell it. And again, of course, say it's free. Well, Excel, you have to pay for Microsoft to get that, but it's reproducibility and the ability to check your work, because there's been many times, I'm sure yourself, I worked in the oil and gas industry, you get sent an Excel file and then someone goes, aye, that's definitely the data you need, and then you get, once you start doing your work in it, the next day you go, oh sorry, that was the wrong file, I didn't filter it the right way. Well, if you do it in pandas, you'll explicitly see all the steps are done and there should be no ambiguity. So that's the way I would try and sell it, is it's really clear for anyone to understand. I hope that answered your question.
So I just saw that, just so we won't have time for more people. If you're wanting to speak up at another time, we'll have to arrange a call to answer more questions related to the pharmaceutical industry, if that would help. Okay. Sorry, I just saw a notice there saying to move things along. Sorry. What was the next question? Sorry.
From Dennis Devene. I have no experience of this, so apologies if that's a very basic question. Will this take data straight from automated systems, or do you need to extract the data and then put the data into another format before these systems can analyse it? Can it be used on live data from these systems?
Yes, it can be used for live data on the systems. You just have to develop an API that can read from your given existing data store, data reservoir, or what it's called. But it can be done. It can be used in real time.
And there's many examples of it being done, so it wouldn't be anything, you wouldn't be reinventing the wheel if you had, say, a data storage which was slightly different to what you've seen online. It is definitely possible.
Yeah, as long as you've got appropriate connectivity set up to access your data straight into the computer or computer cluster that has Python running on it, as long as that's in place, and that was kind of options such as Profinet that Andrew was touching on earlier. So as long as that's in place, then it's very easy and very, very commonly done. And sorry, not easy to be dismissive, but it's very possible to do that.
Yeah, well, hopefully we answered your question there. And then the next one is Kathleen. We have been working with Microsoft Power BI for low-level data processing. Is there the ability to have Python connect with Power BI for presenting the data visualization to keep it consistent? I would imagine so. I need to double check unless any of the guys have worked explicitly with Power BI.
No, I've not actually worked with that. So I can't answer definitively, but I believe it should be possible. I do believe it would be possible to do so.
I was going to say, you'll probably be able to input, I'm guessing, Power BI to like an Excel format again, and again, that's where pandas can work with it. So yeah, from a quick search, yeah, there seems to be ways that Python can interact with Power BI, and I would imagine pandas would as well.
I can imagine Power BI would be using some sort of database, and Pythons can access all sorts of database formats from SQL and other ones.
Again, hopefully we've answered that. The next question is from Cameron. Is there an instance where Python is more efficient / better than MATLAB for data processing?
It will depend. MATLAB is a great tool. It's all integrated together. It has libraries available. It's all installed in one package and has regular updates. So MATLAB, what you can do, a lot of what you can do in Python, you can do in MATLAB as well. I say Python is a little bit more advanced because it's got greater flexibility. So you're able to access tools that might not be available yet on MATLAB. Because MATLAB is an enterprise tool and normally gets updated at, I think, 6-month intervals. They do have a lot of machine learning toolkits now available. I still prefer the Python versions of them myself. So I would say whatever you are able to do in MATLAB, you can do in Python. And the advantage is there's zero cost for getting Python up and running.
Thank you very much for that, Andrew. The next question is from Martin. Is TensorFlow a better choice as compared with scikit-learn / Python? What is your comments?
I prefer PyTorch, FastAI, and scikit-learn over TensorFlow. That's my more personal experience. It does depend on if you're dealing with maybe time series data or video data. It will be application specific. It can also be how you approach programming as well. Paul, would you have anything to that?
Yeah, so I actually, when I first got started with machine learning, I dove straight into TensorFlow because it's what some of the people I was working with were using. And it was only a year or two later that I started working with PyTorch instead and moved over. And I found that TensorFlow, when I was first getting into machine learning, was incredibly cumbersome and had all this kind of header code and additional setup for when I was, I don't know if my network had cut out at that point, but I was trying to talk about the difference between dynamic and static computation graphs. And that's one of the key differences between PyTorch and TensorFlow. TensorFlow, you have to set up like all of the setup for your neural network and all of the computation for it before you can even begin to analyze and begin to run it. Whereas with PyTorch, there's a lot more on the fly ability to chop and change what you're working with and quickly run and alter things. So I found in my experience that PyTorch was much more lightweight and kind of much more easy to get into for your first couple of iterations of running a machine learning algorithm. But TensorFlow, if you're used to it and if it's what you want to work with, then it's incredibly applicable as well. And yeah, I know it's really popular in industry as well, and I found a lot of success working with it. But just different options for different problems, I suppose.
Yeah. Well, thanks for that question, Martin. I think this might be the final question, and it's from Rob. Do any of these libraries give the analyst an indication of which parameters are casing changes? So he's given an example. Imagine 5 parameters, A, B, C, D, and E, differing mixes leading to pass-fail. Leading to pass-fail. Could these libraries help direct our attention? So the question, do any of these libraries give the analysis an indication of which parameters are causing changes? Imagine 5 parameters, A, B, C, D, and E. Different mixes leading to pass-fail. Could these libraries help direct your attention?
Yes, I think most of the libraries that you mentioned will have tools to show the correlation of features to given states. Off the top of my head, I know scikit-learn does, and FastAI certainly does. Yeah. For PyTorch, Paul, I think it's the same case as well.
Sorry, I muted myself. Yeah, it is very much the same case. There are tools to track that as well.
So you're able to have a look at your features as inputs to your model, and looking to see the correlation between those features and how they correlate with a positive or negative prediction of a given state.
Yep.
Yeah. And again, like using Matplotlib, and that it was my final slide. You can put it in a plot and show the correlation against all the variables, and that might give you an indication. Again, thank you very much for that question, Rob. Does anyone else have any questions they want to ask? as I say, feel free to email us at nmis-inquiries@strath.ac.uk if you have any more questions, or feel free to tweet us at NMIS_group. As I say, we'll answer all these questions, and in the next few coming weeks, we'll tell you about more webinars we're providing.
Thank you to everyone who attended today. It's a really great turnout, so it's very encouraging for us. So hopefully that was pitched at the right level. As Paul mentioned before, we'll be hosting technical sessions over the coming weeks that will be announced. These will be very much more focused on going through some of the code itself. So it'll be more, the format will be a shared screen going through our Jupyter notebook, which will be building up code progressively to try to show some of the impact that Python can have on analysing data. And these will be announced through the same channels that this session was announced, but it's probably going to take place on another day other than a Wednesday. Laura, we'll close off the session then, if that's all the questions.
Yes, just thank you everybody again for joining us today and for all your questions. We really hope you enjoyed the webinar and found it informative. A survey is going to follow shortly via your email, so it'd be really great if you could take a few minutes just to complete that to help us move forward with our webinars and make them as good as possible. And there will be a recording of this webinar for anyone who's missed out or you'd like to let anybody know about it, and that will be on our YouTube channel in due course. Thanks everybody so much for your feedback so far. It's really, really encouraging. And thank you so much to our wonderful presenter today. I'm going to close the session now, but thank you again, and we hope you'll tune in soon.
Thank you very much, everyone.
Thanks, everyone. Have a good day.
Thank you. Have a great day, everybody.
Bye.
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 Bye.